Hello, Graph Nodes. We're here. I know someone in the live chat said we were late, and they're right. It's 11:31 now. Technically, we are 1 minute late. So sorry for holding you guys up. We were getting ourselves set up. So thanks for joining us today. We have Igor. I'm not going to pronounce your last name because I feel like I'm going to mess it up. Rozani?
Yes.
Rozani, I did it good. Okay, Igor Rozani, who's going to be doing a talk on his project, the Mega Evolution of Pokémons in a Graph. If you watched before, you might know me. I'm Corrine Wallach. I'm the community manager at Neo. And we have Mark Needham. Hi, Mark.
Hello.
Developer relations engineer at Neo4j. Yeah, I think we can get started, right? Is there something else I should say, Mark? Oh, live chat. Live chat.
Yeah, so if you have any questions, you can ask those in the live chat if you're watching live. Otherwise, we'll put a link to the Neo4j community forum, and you can ask those if you're watching afterwards. Igor's going to be showing some code, I think, at the talk, or at least some views of the Neo4j browser. So you'll want to make sure your resolution is set to 720p or higher. And I guess the other thing is we found the project, the Pokemon project, on a random sort of search of GitHub, and we're like, oh, this seems very cool. So so I'm looking forward to this one. And I guess maybe we can hand over to you now, and you can introduce yourself and the project as well.
Okay, let me just share my screen.
Okay, I'm going to set you as a presenter.
Cool. Yeah, I can see it now.
So it's showing? Okay.
Yeah.
So I'm going to present to you guys the Mega Evolution of Pokémons in a graph. Before starting, my name is Igor Rozani. So I'm from Brazil. And I have been working with software development since 2010. And mostly of my experience is with .NET applications. And I got into Neo4j recently, and I started doing a few databases just to know it a little better. And if you want to contact me, these are my contacts. It's basically Igor Rozani everywhere, so GitHub, LinkedIn, Medium, or in the Neo4j community forum.
Yes.
and this is a quick summary from my presentation. So I'm going to talk what is this project, the page that I utilized, the scrapper, the database, and what I'm planning for this project. So the project is kind of simple. It's a scrapper that reads the Bulbapedia database, the Bulbapedia pages, and transform it to a Neo4j script. If you don't know what is the Bulbapedia, let me find here. Bulbapedia is a famous encyclopedia about Pokémons. So I basically come here and read the data from the page and generate this script. It works like the Bulbapedia works like a Wikipedia, so it's open for everyone to change and add more informations. And they are really rich information about Pokémons here. So since it's a scrapper, I need to scrap some pages. So which page I'm utilizing? I use 4 pages from the Bulbapedia. That's one is the list of Pokémons. So here you can see all the Pokémons that exist in the Pokemon world, and they have just all. And when I started watching, it was only 150, and now it's more than 800 Pokemons. And in here, in the end, there is these ones with not so much information because they were not released yet. It's just for the new game. The second page that I utilize is the list of Pokémons by evolution family. So here you can see all the Pokemon evolutions, all the information that you need to see who evolves to what and what you need to evolve. The third page is the list of Pokemon with forms difference. So here you can, after the generation 2, they started to include Pokemons with different forms. So, and here you can find all the data that you need all the information from that different Pokémons. And the last one is the Mega Evolution that was introduced in the generation X and Y, that the last evolution of a Pokemon can Mega Evolve to a new Pokemon temporarily. And here you can see all the possibilities. Oops, wrong. So this project, I split it in two repositories in two different projects. And one is the scrapper, and the other one just the database. So the scrapper I developed using C# with .NET Core, and it's just a console application that you go and read all the that goes read and generate this script. Let me close out this. Okay. So if you this is the Visual Studio with the project, okay. And so if you're not familiar with .NET, in the program is where all the magic happens. So here I go and call everyone, call the, let me run first, sorry. So in the program is that where it runs the main application, and you can see here that what it does. So it goes scrap the list of Pokemon, the Mega Evolutions, the evolutions, the forms, generate a script and save this file. Pretty simple. To be able to run it, I had to create a few configurations that you can see here. So I have the Bulbapedia configuration that basically I have all the paths from the page that I need, the images, and where I'm going to export the file. A curiosity is that when you go to the Bulbapedia, let me open a page here. The link here, it's not the real link. They have kind of alias. So when you try to scrap this page like this way, will not work because it's going to redirect, so you don't have a real HTML to read. So I had to find the real link, and that's why they are different. So the Mega Evolution, this link is exactly the same thing as this one. So, but this one is possible to grab the data. In my project, I separate in a few contexts. So I have just the representation of that configurations in some class here in the configuration, and then I create the models that is the representation of the data that I grabbed in this relational, in the object form, so in a class. So here you can see the Pokemon and all the data that I'm grabbing. So the numbers, the name, the picture, the profile, all the types, evolutions, forms, mega evolutions, and regional variants. So here it's basically the basic structure that I will use to generate the graph database. And here in the service, I separate for 3 little contexts. So I will follow just in order here from the application. So to be able to run the project, to be able to scrap these data, first I need to go and grab the Pokémons that exist in the Pokemon world. So I came to this page, and I basically read all the data from this table. For reading this was kind of simple. I looked for the main div in the page and look for all the tables, because these are all tables. It's split by generations, but there's a lot. But they are just tables. So I just came here and read the data from the row. So read the number, the regional number, and the national number, the picture, the name, and the types. So this is here in the scrapper, and every scrapper has its own folder. So the first one you need to run is the Pokemon list. And here I come and it's pretty simple. As I say, just read the data. And from this page, I capture two different data. The first one is, of course, is the Pokémons and the regional variants. That is because in the Alola version, they release some new weird Pokémons that are different from the traditional ones, like this one, that's the Sandshrew. So there is the normal and this Alola version, like Sandslash and Vulpix and other ones. So in this first scrapper, I go here and read this table, these two data, and generate a list that I'm going to use in the other parts of the scrapper. Okay, so the second scrapper that I goes is the evolution. So I came to this page and again look for the tables on it and go and grab all the evolutions. So here I grab what is the condition and who evolves to who. And this page was a little more trickier because there is not a specific patterning like this one. That's always a Pokemon with all the same. But here there is Pokemons that can evolve 2 times, Pokemons that can evolve only once, that can evolve once and have 2 options, or just Pokemon that doesn't have evolutions like Farfetch. So this one I have to do a lot of treatments to see what I'm reading and how to fix and going fixing it in my how to fit it in my objects. So here you can see that there is a lot of ifs and specific codes for that. And from this list, I grab two kind of data: the evolutions and the unknown forms. Where is it? Here? Because here is the best place that I found about the unknown, that they have his specific forms. Okay. So after it, I went to the Mega Evolutions, and the Mega Evolution is kind of simple, like the list of Pokémons. I only come here and grab the table and go checking, grabbing the data. So to Mega Evolve a Pokemon, you need the Mega Stone, and the Mega Evolution can maybe change the types. So I had to scrap it through, and just that. Here I only grab the Mega Evolution and the Stone. And it had a few tricks that, like Charizard or Mewtwo, that they have 2 Mega Evolutions. So it's just that I read and generate this data. Again, I grab the list of Pokémons and update the list with the Mega Evolutions for the specific Pokémon. And the last scrapper that I created is the scrapper for the farms. And this one was trickier too, like the evolution. Because first off, there is a few evolutions that's not sorry, a few farms that are not actually farms. It's just a Pokemon with dresses like this Pikachu. So I decided to ignore it, and they don't exist in my database. And as I showed before, the unknown here is kind of bad showing, so that's why I decided to grab from here and not from the farms. And if you are not just familiar with Pokemons, these farms, they are like, there's Pokemons that can go and change farms according to specific triggers, like this cast farm that depending of the weather will become one thing. Or there is Pokemons that they can just change farms for depending what he wants to do. And there is other ones that they are just variations of the same Pokemon. So here I came and and look for two kinds of specific tables. So I look for this kind of table, like this one in Deoxys, and the ones in the like this one from the cast farm. With these two, I was able to read all the forms from the Pokémon that in this database. So these are the 4 scrappers that I created for now. And after it, I had to create, I had to export my class, that's my class of Pokémon, and generate a script. So for this, I created my class basically that will generate this script for me. So first off, I create a class that was able to create the create command and the relationships. It create commands from nodes and relationships. And here I basically pass by the Pokemon, which Pokemon, and go organize it in the structure that I created. And after you're running, you can just, sorry, you can just come here and see that this Pokemon's file, and here is all the data that I get from the Bulbapedia. So you can see all the types, all the Pokemons. There's a lot of Pokemons. All the forms, Alola versions, Mega Evolutions, and the relationships between the nodes, that are the evolutions, the other things. So basically my scrapper is that. You just go read and generate this script. And with with all this data, I created this database. So I decided to create only 4 types of nodes. So I have the nodes of Pokemon, form, type, and Mega Evolution. The type is pretty simple. It's just a name. And the Pokemon, as I show you, like here in the page, you ready? Here. So I'm saving all this data that is showing here. I generated this node with this information. So it has the number, the name, the numbers, the pictures, and the profile link for the Pokemon. That is this link. So since a Pokemon has a type, since a Pokemon is from some type, I had to create this relationship between Pokemon and type. So a Pokemon is this type. And in this relationship, I just decided to not store any data, just doing the relationship. And a Pokemon can Mega Evolve. So a Pokemon Mega Evolve to a Mega Evolution. And as explained before, the Mega Evolution has a name, and I grab the name and the picture. And for trigger it, you have to have a Mag Stone. So in the relationship between these nodes, I decided to store the Mag Stone and the image in the Mega Evolve type relationship. And a Pokemon can evolve to other Pokemon. So and to evolve, you have to have specific conditions, sorry. So it can be by leveling up the Pokemon, can be using a specific stone, or for knowing some move. So because of this, in the evolve, I decided to store the conditions of this. And then I've included a Pokemon that evolves to another Pokemon. And the last data that I have in my database is the forms. So a Pokemon can have multiple forms or just one form. So in the form, I decided to store the name, the picture, if it's Alola, and if it's interchangeable. So the regional variants that I commented before, that is the Alola specific Pokemons. I decided to not create a specific node, and I just keep it in the farm because basically they are the same. They are just a different farm from that same Pokemon. So they are stored here, and I identify it with this Isalola field here. And this, it's important to know that this is interchangeable because, as I said before, some Pokemons can just change forms depending of the trigger, like normal, some like this cast form that can trigger depending the weather, or this depending of what kind of moves you wanna do, and this one according to the season. And there is Pokemons like this one that they just can change. If they were born in the West Sea, they are pink. If they were born in East Sea, they are water. Oh, sorry, they are blue. And since the and just that, so a Pokemon has a form, has different forms. So this is the representation of this kind of data. And and since the forms and the mega evolutions can have different types, I decided to recreate the relationship between the Pokemon and type in the form and type and the mega evolution with type. So both has the specific relationships for that.
Igor, a question for you
Yes.
before you move on to that. Just for, I guess, for people watching, is this the first graph model you've created, or like what? Maybe you can explain a bit your process of learning how to do graph modeling.
Okay. Uh, this is not my first modeling project. Uh, oops, I closed. I'm sure I have here in my GitHub. I created one before that was a mapping of. So in São Paulo, the city has this metropolitan transport network, and I used this one to study Neo4j and create my first project, starting to understand how to model the data from this. So I basically grabbed this image and generate this. And
Oh wow, that's that's a much more complicated one.
yes, it's a lot more complicated. It's still not so good. There's few data that I don't think I still put it right. I want to refactor it. But with this, I spent a few months trying to breaking my head and discovering how to create this database study. And after that, when I got a little happy with this, I decided to just create another project like this one with the Pokémons, because I wanted to develop a scrapper, and I wanted to study a little more from Neo4j. So I decided to unify these two projects in just one. So I create my scrapper and my other database with Pokémons.
Cool. So if you were like, say someone's watching and they've never done any graph modeling or never created a graph before, what would be like your main piece of advice? If I've got a data set, like I found a website, I scrape it, how would I decide what should be a node, for example, like as a starting point?
So I watched some uh, videos on the YouTube that were explaining the basics. So there I saw what is a graph, because when I started, I will be honest, I knew nothing. And I saw it, and I thought like, what a weird database. And so I started to trying to understand better and where to apply it. And I watched some YouTubes. And then I started to, and let me,
Ah, the graph gists. Cool.
yes,
Okay.
there is this good example of projects that here in the Neo4j website that I used to learn about it. Even there is a one of Pokémons that I kind of based in this one too. Uh, Whereas here this the Pokemon XY. It's a really good graph database, and there is a lot of good explanations. And these were basically my guide. These projects and the documentation. the docs from Neo4j.
Cool, yeah. And so just for everybody else, those graph gists, if you search on another tab, maybe for Neo4j Graph Gallery, you can now actually install a graph app into the Neo4j desktop, which has many of those. Yeah, so the top link on there.
This one?
Yep. So if you scroll down, you can see these are now up. You can actually access them directly inside the Neo4j desktop, and you can, if there are guides in there that you can just place straight onto the database.
Well,
cool. Okay,
really
so you would suggest that reading through those gists and trying to find if there's one similar, or if not, luckily for you, in your case, exactly the same as the domain that you would like to model. Cool.
Yeah, it's a really good material that they have there. That
cool.
You guys have there.
I'll let you carry on then.
Okay, and I'm not so good at queries, sorry, but I created a few examples. So let's do it and show what you can find here with this database. So I'm using the Neo4j desktop version, and here I have all my Pokemon and my script running. And let me grab here. So I put all the queries in the repository, so if someone wants to go there and see and play, so feel free to do it. And so the first thing that I created after this was how many Pokemons, sorry, how many types, sorry, how many Pokemons has in each type. So what is the quantity of Pokemons per type? And with this database, we can easily solve this by this query. And you can see here that the most common type of Pokemon is water, followed by normal Pokemons, and the most rare one is the ice. But since a Pokemon can have mega evolutions, different forms, then this count can change a little bit. So basically, knowing all the possibilities of a Pokemon, what is still the most common types? So water is still the most. With this query, we can search and ignore just not looking specific for Pokemon. We are looking for everything. And here we can see that for the water is the most common Pokemon. It is still the most common, but normal is not anymore the second. It dropped to the fourth, and now it's flying and psychic the second, the third. And it's still the most rare one is its ice. Other interesting data that I'm able to grab with this project, with this database, is that which Pokemon has farms and how many farms they have. So you can see here that for the Unknown, they have 28 possibilities farms, different farms. So
are these one-to-one relationships? So you can only have one form and be of one type, or can you have multiple forms or types?
Yes, there is. The types can have, a farm can have max 2 types, but a Pokemon can have any types. Like these Unknown, they are all the same types. Where is it? Here, they are all the same one, but they don't change the specific type. Like here, they are always psychic. But for example, if you go and check where this Pokemon, the Rotom, he has 6 different types. Sorry, 6 different farms, and each farm has a different type. So they are electric and fire, electric and ghost, electric and water. Was that?
Yeah, cool.
Okay. And so in here you can see, yes, I could have included the types and other things, but it was just a really simple curve. The other example that I have here is what are the mega evolutions of a Pokemon. So I go and check in the relationship between Pokemons and mega evolution, and I export here in this table all the wish. So here you have the Pokemon that can mega evolve and what is the name of this mega evolution. So here you can see that most of the Pokemons have only one mega evolution, but there is two Pokemons that can have two mega evolutions. That is the Mewtwo and Mewtwo X and Mewtwo Y, and the Charizard X and Charizard Y. And I have more two examples here. The other example is that what are the different forms and mega evolutions that a Pokemon can have. So I'm basically putting together the two previous queries in just one. So you have the Absol that has only the mega evolution, or you can see that Arceus has all these 18 different forms. And I think it's just this. It's for me, it's an interesting thing. It's a really interesting thing. And the last example that I have here with me is, so you have a Pokemon and you wanna know what are the possibilities of this Pokemon, what he's going to be able to evolve. So here, for example, I have the Charmander, and here you can see that the Charmander can evolve to a Charmeleon that will evolve to a Charizard, and you can have two possible Mega evolutions, that is the Mega Charizard Y and Mega Charizard X. And
So you're using the sort of
see,
star on the query here, right next to the mega evolve. Can you explain that for everybody?
yes. So if you don't put the star, you are going to only grab the next evolution of that Pokemon. So when I put the star, I say I want all the paths from that relationship. So with these, I can pass from the Charmander to Charmeleon to Charizard and the Mega evolutions.
So you do like 4 different evolutions.
Yes.
Oh, cool. Okay.
And
so I guess this is one of the queries. Like you could imagine the previous ones you've showed, you could reasonably easily reproduce those in a relational database. But this one would be, this is now like it's quite difficult to reproduce. It's quite a graphy query, if you like.
yes, this one is the most graph query that I created. And yes, with a traditional database, I would have to do a lot of joins. I wouldn't be able to do that. I'm going to tell you, it would be really complicated. But with this, it's just I put this star and problem solved.
Cool.
And an important thing that I forgot to tell about the model of my database is that I'm not ignoring the direction of a relationship. So mostly in the Pokemon evolve to another Pokemon, because the direction of this relationship is important to know that who is the previous evolution, who is the base, and where he's going to evolve. And a Pokemon cannot devolve. This word doesn't exist, but cancel this evolution, go back to that evolution. So it's really important to considering that the direction of these relationships, and that is another detail here in this query, that there is the direction right here to identify that. And that. And the project is not over yet. I still want to add more data to this database and create more stuffs. So one thing that I want to do is add the moves from the Pokémons. So I want to grab all the possible moves that a Pokemon can have and store in this database. And I think it's going to be really cool to have this data. And do you have more questions? What I have to say is my presentation is just that, so I'm more open for more questions from the chat.
Oh yeah, there's no questions at the moment. You got a lot of fans watching, but they're all writing in Portuguese. So I can try and guess what they said. But
They say they were going to do a little math in the chat saying that, and I spent to everyone I know.
It's funny.
Yeah, so I guess I can think like what would you do like if you did your project from scratch again? Like what have you learned from doing it? Like what I guess I don't know. What lessons have you learned that if you did it again you would do differently?
Well, I learned with it's a simple project, but with that I learned a little more about the relationships. My previous project, I was ignoring the direction in a relationship, so it wasn't important. And with this, I learned that the importance of a direction in a relationship. I know that there is case that will not be important, but here I think it is. And it was in the start was really complicated to put the data in the right place. So for example, in the farm, I'm still not, let's show this slide. In the farm, I'm still not so happy about the place that I put is interchangeable, or if it's Alola, maybe should be here in the has. But I don't know, maybe in the future it can change. But
yeah, I think for that one, it kind of sort of depends, right? Like if you were to move it to the relationship, then what you're kind of indirectly saying is that there could be two Pokemon where they both have that relationship to the form, but it's possible that they have different values for is interchangeable and is Alola. Whereas if given that they are a particular form, they always have the same values for those two things, then where you have it is absolutely fine. The only reason you would move it is if there was some reason why it might be different for a specific Pokemon.
okay, so it's right. So since it doesn't change, so I think in the end I put it in the right place.
You're just kind of duplicating the same information, and there's not really any advantage to doing that. One thing I noticed, which works fine in this example, but I would do differently if you had to work with a bigger data set, is do you have your Cypher script where you created all the data handy?
Yes.
So I think you did it actually exactly the same as what I'd done on my first graph project. You generated like all the Cypher statements, all the create statements.
Yes.
Yeah, so this works really well for small amounts of data, but if you have to deal like with, I don't know, how long does it take to run that actually? Is it pretty quick?
Yeah, it was pretty fast. I can run here just to show you. Yeah, because there's not so much data. So
yeah, if you were working with a bigger data set, what I would do instead of generating the Cypher, because it takes a long time for it to compile and run. If you generate the script, but this is exactly the way you would likely do it if you had done the SQL before. An easier approach is to actually create some CSV files where one row is representing each of the items in here. And then you can use the load CSV command to iterate through the CSV file and go and either create the nodes or create the relationships between them. And that'll work for for this one, it's absolutely fine. But if you were to work with a bigger data set, say with hundreds of thousands or millions of items, then it would handle that better. If you tried to generate a million rows of this, you probably crash the Cypher compiler, I expect.
Yes, I didn't know about this way of creating database, but it's a really interesting. And yes, for this one, I wanted a little bit just to, since it's a short, I don't think it would be a problem. And another thing that I could have done is connect to the Neo4j and insert it element by element in not generating a script.
Ah,
You know,
from your from
from
the C# code.
yes,
Yeah, yeah, that's a good idea. Yeah, that's maybe another way, yeah, that you could do it.
yes, yes. As you are seeing, there is a lot of improvement yet to that I can do in this project.
Yeah, it's always the case, isn't it? Any project you build, there's always some things that you can change to it. But I think it's really nice what you've done already.
Thank you.
Great job,
Uh,
Igor.
thank you. And okay, and I don't know if you have more questions, but before that, I want to thank you, Mark and Karen, for this amazing opportunity.
Oh, and thank
And
you for, creating the project and agreeing to present.
okay, thank you.
Uh,
Yeah, I was really happy for this opportunity.
oh, yay, we're glad. That's awesome. And we're really glad that you're, able to share and everything, because I think that a lot of people learn from it, as well as you. There's some things that, like, just with Mark, just giving some feedback and thoughts on it, too.
Yes.
I think that's helpful, too. So, as you mentioned on this slide, there is the community thread. So if people are not watching this live and have questions, you can go directly to the community thread. I actually posted it earlier in the chat. And then you can talk to Igor directly and ask him questions or, comments, anything. So, and I think that's it, right?
Yeah. And then next week we're doing some football, right? I think.
Oh, yeah, Bia.
Mhm.
That's
Yeah,
going to
so
be a good one.
maybe we can I'll put a link to the meetup page if you wanna register and grab the YouTube live link for next week's one. So same time again next Thursday. And again, shameless self-promotion. Don't forget to like the video so that other Pokemon fans and Neo4j fans can find
Yes.
it.
And before I forget, I have to thanks Koji and Nora. Sorry if I say the wrong
Oh,
name.
yeah, Koji.
Yes, he did a nice code review in my script. He saw that there's some stuff not following the patterning from the cipher.
Oh,
So
nice.
he helped me with that. And
Oh,
thank you
yeah.
so much, Koji.
Koji's amazing. Where did he help you with that? How did you guys connect?
He emailed me. He saw my project and he mailed me with the changes that.
Oh, so he saw it on the community site.
Yes.
Oh, very cool. Yeah, Koji's amazing.
Mm-hmm.
That's nice of you to thank him on the meetup. All right. Well, thank you again, Igor and Mark.
Yeah, and thanks everybody for taking the time to watch. And if you have any questions afterwards, yeah, don't forget you can ask them on the community side or you can ask them in the YouTube comments.
And we will see you guys next week.
Cool. Thanks everyone.
Bye.